First of all, I would like to sincerely thank BUBT to give me this opportunity to come and present my research. I would also like to sincerely thank the honorable members of the trustee board, a dear friend and colleague, Professor ABM Shaukat Ali, the respected faculty members, and other staff and students for listening to me. My name is Ashfaqur Rahman. I'm based in the beautiful city of Hobart in Australia. I am working for CSIRO. Over the next few slides I'll be talking about me, but the purpose of the talk today is basically to share my experience over the last 12 to 13 years working across different Australian industries and using artificial intelligence and machine learning across different industries to solve real-world problems. First, starting with my organization, I joined CSIRO in 2012. CSIRO stands for Commonwealth Scientific and Industrial Research Organization. It's Australia's largest and one of the world's largest multidisciplinary research organization. It was founded in 1916. As of now, I think it roughly employs around 5,500 employees, most of them researchers. We work across so many different disciplines, including agriculture, mining, energy, manufacturing, computer science, and lots of different other disciplines. We work with so many industries, ranging from Boeing, Microsoft, Google, and lots of local Australian universities and also Australian industries. Most of my work that I'll be presenting today are with Australian industries, but I do have some work with US industries as well. I joined CSIRO in 2012 as a research scientist. Since then, I had to go through so many transitions before I came to my present role. I work as a principal research scientist there. I lead a small group of researchers, roughly 55 of them, mainly in the areas of machine learning and its applications. They're divided into 5 different teams. I work for the division of Data 61. That's an interesting name for a division, actually, especially with 6.1. 6.1 is actually Australia's country code. So that's how our former divisional head came up with this name. Within that, we have got 4 programs, and ADS, which is Analytics and Decision Science, is one of them. And I belong to that program, the specific group, the one that I lead, which is Statistical Machine Learning group. About my background, I did my PhD from BUBT. I hope you know that from 2001. After that, I worked in BUBT for a few years as a lecturer, and then I moved to Monash University for my PhD, which is actually image processing. But I think my roommate and also was my colleague at that time, Professor Shaukat Ali, who at that point in time was working with machine learning, and that sort of was more inspiring than image processing anyway. So that sort of inspired me to do a postdoc after my PhD in machine learning, and that was also at Sikh University where Professor Ali worked. And after that, basically I joined CSIRO. In between, I did part-time teaching at Monash University, Sikh Uni, and some other organizations. Currently, I'm a senior member of IEEE, and also I am editing this journal, which is an Elsevier journal on information processing in agriculture. Next, actually, I would like to give you an idea of my area of research. Machine learning actually it's a part of artificial intelligence, right? What's the difference between artificial intelligence and a normal thing? A normal machine, actually, when it's programmed to do something, actually it does the same thing over and over, right? It doesn't do anything different. But when it comes to AI, actually, it has the liberty to decide what to do next, right? So imagine, actually, if you're thinking of the Tesla cars, right? They're fully equipped with sensors and so many machine learning algorithms and AI sitting in them. And when they go for autonomous driving, with the sensors, they perceive the environment around them, and instantly make decisions if it comes to braking, or if it comes to switching lanes, or if it comes to speed up, or whatever, right? Or if you just ask them for do an auto parking, it does the same.
Yes, sir.
So which means what it's doing next, it actually depends on its current state and the environment it is in, right? So it's not doing the same thing again and again. So that's what actually artificial intelligence does. And when it comes to machine learning, actually machine learning is all about data. I mean, today, even when you're sitting, actually somebody's taking an image, I'm speaking, this is an audio, somebody's taking a video, right? Each and everything that around us is data in some way, right? And machine learning algorithms, or what they do actually, they develop methods to translate this data into something meaningful, something that can be used. I'm pretty sure a lot of you have heard about ChatGPT, right? What is ChatGPT, right? For example, if you go to ChatGPT and just do any kind of query, it will just deliver something for you. So a few weeks back, it was just out of curiosity, right? I thought, what about I do some experiments with ChatGPT? And I asked, can you write me a request for leave in the Shakespeare language? And you'll be surprised the response I got. Actually, it's full of die and all these kind of words that you commonly find in Shakespeare novels, right? And it wrote me that. And then out of curiosity, I asked, can you write me a leave request in Donald Trump language? So imagine the response I got. So, and the responses were like, if I come back from leave, you'll see I'm going to make this workplace the greatest in Australia, America. Right, so as you can see, it somehow learned how Donald Trump is going to speak and delivering this in, right? So it had no idea that actually I was going to ask this question before. So it decided on its own somehow that actually it's going to make a response like that. But these ChatGPTs are trained on billions and trillions of news articles, novels, and every kind of data that's available all over the world to come up with this kind of a language model. Actually, when you query it, it's going to give you a response like that. So that's what machine learning is, or the power of machine learning is, right? When I gave you the example of Tesla, actually it does a lot of image processing or computer vision to understand the images, what's there, whether there is a traffic signal, should I stop if that signal is green or right, should I move? Actually, when actually I'm perceiving a car in front of me, should I slow down, right? So a lot of data that it uses using methods to make its decisions. In machine learning, actually the work varies from pure academic focus, actually, which are foundational methods or models which can range from deep learning and so many other kind of methods, to on the other side, which is on the applied side, which means there is an algorithm, you just simply pick it up and just put it in solving a specific problem, right? So the Tesla and all these are basically on the applied side of ML, right? But on the other extreme is the foundational ML side. Within my group, actually, we work across this whole spectrum, from foundational work to stat ML, the applied work. In the last 5 years, our group produced around 50 top-ranked conferences and journals. Actually, one of our researchers, Lina Yao, I think she recently reached a landmark of 20,000 citations. And I think our group is basically one of the top-ranked in the world, to be honest, especially when it comes to foundational science. On our end, actually, my specific research actually falls more on the right-hand side, which is on the translational side to the applied side. So in the rest of the slides, I'm just trying to manage expectation here. So what you're going to see is a different range of applications that I'll be talking about. What we used here are different machine learning models to solve this problem. I'll possibly ignore going into the details of the modeling part, but try to focus on the application side of things. So this is the range of applications or the areas where we work in recent times, I should say. Like environmental applications, aquaculture, agriculture, mostly livestock, energy, the top 2 AI for design and FDM if they're more in manufacturing. I do a fair bit of work with Boeing, but obviously we have a lot of contract restrictions. We really cannot talk about those works. and I've got some PhD projects with different Australian universities. So from now on, actually, I'll be talking about the different applications, mostly the problems that we solve. So this is more of a project from the past. I'm not sure actually how many of you are familiar with shellfish. Yeah, whatever. I mean, from the image, I'm not sure how clear those things are. Those shellfish, especially in Tasmania, they are grown in waterways. So the farmers basically lease part of the waterways to grow the shellfish. So what they do, they fill those trays with the shellfish, they submerge them into water, and the shellfish actually, when they open their shells, the meat gets in touch with the water. So if the water is contaminated, there is a very good chance that the meat itself will be contaminated, and there is a significant health risk. So there is this program in Tasmania which is called TSQAP, or Tasmanian Shellfish Quality Assurance Program. Their job is to basically monitor the water quality. But what happens if the meat gets contaminated? The farmers basically lose their production. There is no way that they can sell those things, and they just need to throw it away. So it's a significant financial loss. So what we were tasked with was basically to predict those closure events. So given historical data of when these water contamination happens, especially when there are a lot of rainfalls and runoffs from the nearby shores to the water, that's when actually this kind of contamination happens. So can you use machine learning to solve these problems, right? If you have time, I'm more than happy to go into the modeling, but that's where actually when we used machine learning based on historical time series data to solve this type of problems. This is another example, but this is mainly in the prawn farms. So on this work, actually, we worked with this prawn farm called Pacific Reef. They're based in Queensland, and they have got so many ponds where they actually grow their prawns. Interestingly, to grow prawns, you need to maintain the water quality in certain ranges. So if it's just too saline, it's not going to grow. If the dissolved oxygen is too low, it's not going to grow. If the temperature is too low, it's going to die. The prawns are going to die. So you need to maintain them in certain ranges. However, you need to do a lot of additional work to maintain the water quality parameters in these certain levels. So if you have to do that, you need to do some continuous monitoring and also need to predict when some kind of adverse situation might happen. So that prediction part was something that we worked on, and on the left-hand side, that deep neural network that you can see, basically it's a transformer network that we use to make these predictions, and on the right-hand side is basically the app that you see that we have developed for the farmers to use. On the very right-hand side, you see those meters. Actually, that sort of shows actually what are the predicted water quality levels for the ponds for next few days, and that's how actually they make the decision, basically more in a reactive way to address those problems. So that's about water quality prediction. This is an interesting one. So this was more about automatically measuring the growth of prawns. So the way things work in the Pacific Reef or these kind of Australian industries, there is this growing season of roughly 12 to 15 weeks. So they put the larvae into the ponds, and in next 12 weeks or for 15 weeks, they have a target range of say 18 to 20 grams. That's where actually they want their prawns to grow. But as part of that, they need to regularly measure the prawns just to make sure that they're growing adequately. To do that, what they do basically, they cast nets. Cast nets means, anyway, I'm pretty sure you've seen fishing nets, and they throw it out to pull the prawns out and basically measure them. But that process basically kills off a lot of prawns. So as a result of that, what they wanted was actually, they wanted an automated process to see if we can measure them. So what we did actually, we designed this headset that you can see. It actually hosts a Raspberry Pi unit on the back, a depth camera in the front, and also a Google Glass. With the help of these three technologies, actually as you can see those trays on the top right-hand side, when actually a farmer pulls out those prawns, those cameras capture those images and basically use a deep learning network to automatically detect and measure those prawns. as a result of this, actually, you can just do a completely hands-free operation, and I think that productivity goes up. So that's one of the, actually this is already in practice being deployed in factory, and a significant improvement in the day-to-day operation. This is the whole workflow. I'll also skip this. This is another interesting application, and yeah, like in particular in Queensland and Northern Territory, the farmers who are growing their cows or beef, actually they cover a significant amount of area. Any idea how big a farm can be? We are talking about maybe thousands of acres of hectares, right? And it's next to impossible for a farmer to go and monitor. Sometimes they pull out their helicopter to go around their whole farm to monitor them. So basically they wanted an automated monitoring of their cattle breeds. So as a result, CSIRO on the left hand side, you can see that blue thing, that's called a collar tag, and that was developed. The idea is actually with these sensors, they house pretty much like a smartwatch. They have all kinds of sensors in them. So as the animal moves, it can basically capture all kinds of movements within the animal. And the idea was, can you infer meaningful information about animals' behavior out of this? And this can be used in so many different applications, like animals' health. Like for example, you can find out like how much feed intake or supplement they need to be provided. You can find instantly where the locations are, and in birth difficulty detection, and so many other interesting problems. So these are some of the applications actually where we worked and used machine learning to solve these problems. This is more of an application in manufacturing. Like, actually the objective of the project was to basically design a filter. Now you know the purpose of a filter, right? So for example, filter obviously blocks something or absorbs something, right? So in this case, actually, they were inserting this filter inside a tube, and the idea is actually when the fluid flows through this tube, how much carbon it can absorb. So the idea is actually to reduce the amount of carbon from the fluid. Now, what is the best design of these filters? Like, how can you design this filter so that you can maximize the absorption of carbon from the fluid as it flows through it? Now, this is more of a optimization problem, and we basically worked in two steps. First, to design an optimization algorithm where a genetic algorithm was basically used to find the best design. And this is a very time-consuming process. So for example, the genetic algorithm directly works with a computational fluid dynamics model. And the fluid dynamics model basically simulates this whole scenario where it should put this filter in, and it finds out how much carbon it can absorb. Combined, actually, we did some extremely good results, and we have applied for 4 patents out of these filter designs. So that's another interesting application. This one may be very interesting from Bangladesh garments industry perspective. Like when there are lots of workers or staff working in a manufacturing or an assembly area, it's really hard to monitor them. So monitor like what kind of work they're doing, how much is their efficiency. You have got a lot of vehicles and human working together in an environment, to considering the safety of the workers. Actually, how do you ensure who is where and who is doing what? So in order to do that, actually, CSIRO has developed a technology, actually 2 of them, but they're basically for indoor position monitoring, or it's called IPS. I'm pretty sure a lot of you are familiar with GPS, right? Which is Global Positioning System. So most of the cars nowadays and your phones are fitted with that. So if you're in an unknown place, you can use the GPS to find out a track, right? Imagine to a nearby place. IPS is more on an inside setup. So if you look at the GPS, if you go to that door, if you come here, it will give you the same GPS location, but not with IPS. With IPS, it can tell you precisely where you are at a given point in time. And for that, the CSIRO developed technology is more of computer vision based, so they use a set of cameras to find out your location. And the other one was more of a tracking device based anyway. But we were tasked in this project to find out what kind of information can you get out of it. So when a worker or a staff is working in an assembly area or a manufacturing industry, what kind of information can you get out of them using machine learning or AI? So these are some of the things that we worked on. So we worked on 3 types of activities. One is just to find out some meaningful patterns in the data. So this one on the left, as you can see, once you know the locations of all the workers for all over the time, so these are some of the things. So when you expect a worker, so the top left top diagram is basically showing you expect the worker to be in these 2 positions for this whole period of time, because that's what they're tasked with. But when you look at their actual movement, you find that these are the areas actually where they interacted through this whole time. So obviously they deviated significantly from what they're expected to do. So these are some of the things that you can use for measuring their performance or productivity and all this kind of work. The right-hand side, from this information, you can find out the interaction between workers. Imagine 2 workers are supposed to work together for a significant period of time, right? But this diagram is suggesting which worker and which region they're interacting with. So the level of interaction across different regions in the workspace. So these are some of the things that you can use to take decisions or understand workers' performance. These are some of the works that we did to understand workers' activity. So whether they were in the assembly zone, whether they went out to find a particular tool, or whether they just took a break, or different 6 or 7 different categories of activities that they were doing. But the idea is basically, can you understand what the workers are doing based on the data that you're receiving from the tracking devices or these IPS systems? This is more around abnormal behavior detection. So on the right-hand side, the diagram is telling you actually over the period of time what the worker was doing in this 3D space. Not in the 3D space, actually it's a 2D space, but the 3rd dimension is basically the time, the movement, and you can use this to find abnormal behaviors. And this is something important in manufacturing context or in an assembly line. So for example, if a worker is doing any kind of risky moves over time, that can be injurious to health, and for Australian industry that's a very difficult thing because they need to pay out a lot for injuries and all this just to avoid those kind of situations. This is a good example of application in environment, the one that we talk about right now. So Australia has this organization called BUM, or Bureau of Meteorology, and they collect weather information, pretty much like our Abhawa Odhidottar, right, in Bangladesh. So they're Australian equivalent. Now, what they do actually, they set up these weather stations across Australia. So maybe there are 100 or 200 of them. So as you can understand, Australia is a huge land, and 200 sensors, 300 sensors is not sufficient to cover large geographical regions, right? So what is the problem here? The problems are the farmers. So imagine I'm a farmer, and actually I'm growing, say, wheat, okay? Or I'm, say, growing grapes. Now, as a farmer, I can take out an insurance. And what this insurance is, actually I'll tell if the temperature falls below 5 degrees, at a given day, the chances are that all my crops will be damaged. And if the temperature falls below 5 degrees, the insurance company is going to pay me $10 million. Okay, that's what the insurance is about. Now, you see, like for example, you can buy basically a small weather station from Amazon, eBay, from anywhere, right? We have stores like Bunnings, they sell them. So you can buy one of them and install on your farm, right? And now imagine a thermometer or that something that's that station that's sitting on the backyard is giving a reading of 4 degrees. And the farmer is claiming the temperature has fallen below 5 degrees and you need to pay me $10 million. So obviously the insurance company needs to verify if this claim is genuine. But can you do it just with BUM stations? The nearby BUM station is possibly 50 or 100 miles away. So you cannot use that data to verify this kind of claims. So that's when actually BUM reached out to us. Can we use a verification model for this kind of insurance claims based purely on data, right? So that's actually where we worked, and the idea was basically to use different data sources, like for example the satellite data, radar data, the different regression or spatial regression tests, and I think we already developed that product and delivered to BUM. But this is one of the very interesting projects that we did for BUM. As a byproduct of it, what we got is actually a very fine resolution weather data product that we can, we are basically trying to commercialize at this stage. This is the last application that I'll be talking about, and this is in the energy space. So Australia for a long time has adopted renewable energy. So we have got so many areas where you'll see there are large arrays of wind power stations or solar panels covering large geographical areas, especially the areas that are pretty hot, like Northern Territory, Queensland, or even Western Australia. They have got significant solar power. So once you install them, actually they connect to the grid for ensuring the supply. Now, if you're sitting in Dhaka or going outside, you understand the wind is not something that's constant. So wind speed goes up and down, right? It doesn't stay fixed. So as a result, the generation also goes up and down and up and down. It kind of fluctuates, right? It doesn't remain steady. So imagine as a user, I'm using wind power energy, and imagine my light actually is going up and down, up and down, up and down. You're not going to feel comfortable, right? You want a steady supply of power. For doing that, actually, you need to get some kind of forecast. Obviously, how this is compensated is by generating what's it called, fossil fuel generated power, which is basically coal, right? They use coal generated power to compensate for that, which is basically the old school method. But to generate that electricity, they need some kind of forecast. So for example, obviously, if I ask you that actually I need that much coal today, you cannot just simply produce them today. You just need some kind of supply from coals, from different sources to make sure the production is actually smooth. When actually it comes to individual solar panels or windmills, actually you can easily make those predictions because there is a steady pattern and you can use some kind of methods. The challenge that we had, we worked with AMO, which is Australian energy market operator, that's what they're called. They basically asked us to develop this kind of ML method that can be used to make predictions at an aggregated level. So imagine the state of New South Wales, or actually the capital is Sydney, right? So the New South Wales, they have got so many renewable energy sources. When you combine them together, actually there is basically no pattern, or very limited pattern. So given that kind of pattern, how can you make those predictions, right? So that's what we worked on and use different kinds of machine learning models to solve this problem. Anyway, look, that's pretty much the end of my talk or the applications where we worked on. But I'll be more than happy to receive questions or answer anything about this particular topic or anything you want to know about my organization. Thank you.
Sir, I would like to thank you first for your insightful and engaging talk on machine learning in practice across Australian industries. It has been a very informative session, and I have gained, I guess, some insights on how machine learning is actually shaping the various sectors of Australian industries. Now, since I live in Bangladesh, and so my interests are very much inclined towards the understanding of the concept and the application you discussed today could be related to the Bangladeshi business or economies. Now, Bangladesh, like other developing nations, is at the point of the digital transformation, and personally I believe that the machine learning has immense potential in addressing the various challenges in Bangladesh, and unlock the opportunities in Bangladesh also. Now, from that perspective in mind, I would like to ask you a few questions that is very specifically to Bangladeshi parties. So can I ask?
Sure, please go ahead.
All right. Now, what are the primary challenges for Bangladeshi businesses in adopting the machine learning technologies? This is number one. And number two, that how the infrastructure and the data availability limitations in Bangladesh impact the overall growth of the machine learning in Bangladesh. And maybe the third one, that can you actually tell me, because I can see that you graduated from where, can you actually share with us any successful application of machine learning in Bangladeshi business? And if you can share, then I would like to know that what are the measurable impact of machine learning in that case?
Sure.
Thank you.
First of all, I have to admit that actually I don't have a lot of knowledge about Bangladeshi industries. So most of my work, as you can see in the Australian context, the methods that are developed for machine learning, they are not necessarily application specific. You can use these methods to solve any problem as long as there are relevant data and all this kind of thing, right? Before I moved to Australia for the second time, back in 2009, I worked for another university in Bangladesh, AIUB, for a few years. And we did some projects there, and I do remember some students were coming up with solutions like, for example, you know, like the fertilizer needs in the different crop industries. So for example, when you grow paddy, depending on the color of the leaf, you can decide how much fertilizer is needed. And they were developing an app at that point in time. The previous practice was basically you take a sheet where there are different colors, we just put them next to each other and just make a match, and then based on that, you can decide like how much fertilizer is needed. You can replace this whole thing with this small kind of, basically you can take a mobile, just take a photo of that leaf and just send it back, and there's an application can be sitting somewhere in a server, and that can automatically tell you how much fertilizer that you'll be needing, right? This is just a small example. We also talked about using Google Maps and using the vegetation index, which means the greenery and everything, to decide on different prospective, like for example, lands for growth and all this kind of stuff. A lot of things that we use, I think they are transferable technologies. So like the weather products that we were talking about, and like for example the crops, although not for insurance purposes but for other things. I don't know a lot about Bangladesh's prawn industry, but I'm assuming it's mostly possibly Chittagong and mostly the saline waters, that's where actually they're being grown. So those kind of technologies that we were using there should be easily transferable here. So I think these are transferable technologies. That's possibly the answer to your first question. Availability of data is definitely a need for basically training these models. But to me, Bangladesh should be on the other extreme, where availability of data should not be a problem. Because actually, when we work, we have to go through a lot of approval process before we can use the data, for privacy grounds, for ethical reasons, and so many other things. But in Bangladesh, I think there are lots of easy ways to get data. So I think availability of data should not be a problem. The problem would be more of the quality of the data in this case. But I think there are ways to deal with it. About successful applications, I don't know a lot, but I think possibly when it comes to fingerprint verification, I'm not sure 100%, like when actually we get Bangladeshi passport, or actually when you cross the immigrations, actually how do they do the verification? I doubt actually that actually it's anything manual. But if it comes to face recognition or fingerprint recognition, so that should be a good example of where actually AI or machine learning is being used. But I must admit, I don't have a lot of knowledge, so that possibly is the end to my answer questions. Sure.
আসসালামু আলাইকুম স্যার, আমি অ্যাসিস্ট্যান্ট প্রফেসর সিএসসি ডিপার্টমেন্ট মোহাম্মদ শাহিদ। স্যার আমার কয়েকটা কোশ্চেন আছে। ফার্স্ট অফ অল হচ্ছে আমরা যখন রিসার্চ করি তখন মানে মোস্টলি আমরা হচ্ছে পাবলিক ডাটা সেটের উপরে ভিত্তি করে আমরা একাডেমিক রিসার্চগুলো করি। সো আমরা যখন হচ্ছে পার্টিকুলার কোনো একটা প্রবলেম সলভ করতে চাই, সাপোজ আমি আমার দেশের আমি ট্রান্সপোর্ট সিস্টেম নিয়ে কাজ করতে চাই। সো আমি আমার দেশের ট্রান্সপোর্ট সিস্টেমে রিলায়েবল কোনো ডাটা পাই না, আমি হয়তো চায়নার ডাটা নিয়ে আমি হচ্ছে রিসার্চ করতেছি। সো এই ক্ষেত্রে আমরা যখন আমার মানে বাংলাদেশের পার্সপেক্টিভে আমি যখন কোনো রিয়েল প্রবলেমের উপর বা প্র্যাকটিক্যাল প্রবলেমের উপরে কাজ করতে চাই, সেই ক্ষেত্রে ডাটা কালেক্ট করব কিভাবে বা আপনার সাজেশনটা কি হবে সেই ক্ষেত্রে, মানে আমরা যখন কোনো প্র্যাকটিক্যাল অ্যাপ্লিকেশন করব। আর সেকেন্ড কোশ্চেন হচ্ছে স্যার, আমরা একাডেমিক্সটা অনেক সময় নিজেরা প্রবলেম চিন্তা করে নিই বা কোনো একটা কারেন্ট ট্রেন্ডের প্রবলেমের উপর ভিত্তি করে একাডেমিক রিসার্চগুলো করি, কিন্তু হচ্ছে আপনি যখন হচ্ছে অস্ট্রেলিয়াতে স্যার কোনো একটা প্র্যাকটিক্যাল সিনারিওর উপরে প্রবলেম দিয়ে সলভটা করেন, সেক্ষেত্রে ডিফারেন্সটা কি, মানে প্রবলেমগুলো হচ্ছে কোথায়, মানে এই দুটার সেপারেশনটা কি, যে আমাদের আরো কি বেশি শিখতে হয় আর কি, যে কোন জিনিসগুলো বেশি ফোকাস করতে হয়, বা আমি দেশের জন্য যদি কোনো একটা ইন্ডাস্ট্রির জন্য যদি প্রবলেম উপরে কাজ করতে চাই, যেভাবে আপনারা কাজ করেন বিদেশে, সেইগুলা কিভাবে আমরা করতে পারি?
Sure. So let me try to answer your second question first, and then I'll get back to the first one. So when it comes to real-world data sets, right, the challenges are very different from an academic research. The common problem that I see with academic research is that it's based on so many assumptions, right? When you go to solve a practical problem, a lot of these assumptions do not hold. A lot of these assumptions are not true at all. So obviously you can see that the theory is not going to work. So that's when actually it comes how you make it work. That's the real challenge, right? So the translational and the applied side, if you can think of that slide that I showed, on that side the key problem is how we apply that method to solve a problem. And a lot of our challenge goes behind pre-processing assurance, assuring the quality of the data before even we apply. And in a lot of cases we just simply cannot solve these problems. The second thing is about the acceptability. So when you do an academic research, right, you are writing this method basically for an academic audience. So they look at this, how sound the methodology is, how sound the theory is, all thing, right? But imagine a client, they don't even care about your theory, they care about whether this problem goes solved. So imagine somebody is interested in counting the mangoes in their plants. So you take a camera, you move around, end of the day you tell them that many tons of mangoes are there in your plants. And if that estimate is very wrong, they're not going to be happy about it, however sound your method is, right? So your client defines a problem and you need to make sure you solve this problem, right? How you solve this problem is your problem. So this is the main key difference between solving real world problems and academic problems. And finally, when it comes to finding your research or funding your research, there are a lot of funding available on the applied side. On the academic side, depending on which country you are, the funding is very low. On the academic side, but on the applied side there are plenty of funding. So these are the key differences. Once again, actually, when you're coming back to Bangladesh, as I mentioned previously when I was answering to Sir, but I really don't know the problems in Bangladesh context, but depends on actually what kind of transport problem you're trying to solve. If it's a transport modeling problem, then you possibly don't need a lot of data. I mean, obviously, if I think of, say, Bangladeshi road network and Australian road network, first of all, there are additional factors that you possibly need to put in there. So, not a lot of people obey traffic rules here. So there is a signal, but nobody obeys those signals, right? So you need to possibly factor in those kind of things into this process to find out. For example, if you're interested in finding out the congestion patterns on the roads and things like those, There are a lot of additional or different factors that doesn't apply in Australian context, but will apply in Bangladeshi context. I don't know if you, can you be a bit more specific about what specific transport problem you're interested in?
যেমন আমার একটা আইডিয়া হচ্ছে এরকম যে আমাদের রাস্তায় বিশেষ করে মানে ট্রাফিক ভায়োলেশনগুলো অনেক বেশি, বিকজ এখানে ধরার কেউ নাই বা ধরলেও সেটা খুব ইজিলি স্কেপ পাওয়া যায়। তো যদি এমন হয় যে আমরা প্রতিটা গাড়ির জন্য একটা প্রিপেইড কার্ড করে দিব এবং সে ভায়োলেশন হলে এটা অটোমেটিক্যালি ডিটেক্ট করবে এবং প্রিপেইড কার্ড থেকে অটোমেটিক্যালি তাকে চার্জটা করা হবে এবং ভায়োলেশনের টাইম এবং কোন জায়গাগুলো হচ্ছে সেই প্যাটার্নগুলোও বের করতে হবে, যাতে ওই প্যাটার্নগুলোতে অথরিটি আগেই বুঝতে পারে যে কি ধরনের প্রবলেমগুলো ফেস হচ্ছে, যে ওই জিনিসগুলো সলভ করা যেতে পারে। তো এই ডাটাগুলো তো কমপ্লিটলি আমার ডাটার উপরেই আমার মডেলটা জেনারেট হবে বা আমি এই মডেলটা অ্যাপ্লাই করতে পারবো। এই ডাটাগুলো আসলে পাওয়াটা প্র্যাকটিক্যালি কতটুকু সম্ভব বাংলাদেশে?
Right, look, I think now I get your problem. Getting data in any context is very problematic, right? Imagine if you are interested in solving a problem with data from Mars or Jupiter, right? You don't have a lot of data. But what can you do is basically do a simulation, right? You can do a simulation actually where, for example, say you are inserting a number of cameras on a road, right? And you just want to find out if a car drives through it and if it moves and actually bothers the rules. You can just do all these things in a simulation, right? And basically can, quantify what will be the impact of it if you do it automatically rather than having a traffic police or a police officer standing somewhere and catching and violating them, right? So I think possibly simulation is the answer to your question. Because practical data, you're not going to get it. But to be honest, a lot of industries, they want to see a proof of concept first before they go for the real application. So I think you should first think of developing a proof of concept with a simulation model, or even just a toy example. You can just take a lab and basically set up some cameras and just make a car make random moves and use cameras to capture it, just to do a demonstration, and then take it to someone like to the traffic control department or whoever there to see, look, this is something that I've developed. And anyway, I think Sarah was telling me, not for the current government, but for the previous government, like there are some big funding available for startups and things like those. If you have a good proof of concept and if you can take it to those kind of ministry, maybe start and help for those kind of things. Yes.
Simple feedback সেটা হচ্ছে যে RFID ট্যাগ লাগাই দিলে গাড়িতে আমরা যে কোনো প্রেজেন্ট অবস্থান জানতে পারবো। তারপর ক্যামেরার মাধ্যমে নেম প্লেট করতে পারছি। হ্যাঁ, বাংলাদেশে ক্যামেরার অভাব নেই, ক্যামেরা বিভিন্নভাবে ট্র্যাক করা যায় না। এটা কোনো দিক টাকা সেভেন করে যেটা
Yes. Two questions, I think.
As you have shown the applications, you have used the deep learning based architecture, and they are very complex in nature, and they are really, it takes a lot of time to understand the deep learning based architecture. So what will be your suggestion to young researchers like us? Should we understand the deep learning based architectures in detail, or just the basic knowledge of it is enough for to go and apply it in real life problem solving?
It depends on what you want to do with it, right? So for example, as I mentioned, if you want to do your higher studies on foundational machine learning models, then you should go in depth. Try to understand how this neural network is working, which particular layer is doing what, which neuron is doing what. If you need to change architecture, as you know, possibly in deep learning, there are so many different architectures now, right? For different purpose. So you should go in depth and understand if you're interested in the foundational side of things. If on the apply side of things, if these things work, that's what matters. So, most people accept that actually machine learning is a black box model. So which means what goes inside is really not a big problem as long as you can train it properly and use it properly, so that's what matters. So if you're more interested on the applied side, you need to have some understanding, but not in depth. But as I said, it mostly depends on which side of that spectrum you are. If you're on the academic side, then you should go in depth. If on the applied side, then just understanding how it works is good enough.
My question is basically on the industry level. So let's say you developed a model, you researched on it and you published it, and now some company or someone wants to apply your model. So, and you have applied those models in the industry. So what kind of challenges did you face? Or what did you have to change from the original model to apply it on the real field?
Right. It totally depends on the intellectual property agreement between the industry and our organization. So, as I said, I do a lot of work with Boeing, but I'm not allowed to even talk about them. So, there is no way that I can publish those work. I developed these models just for Boeing, and Boeing is the owner of those models. So we have absolutely no intellectual property right on them. There are some, actually, where we develop IP and we make them patent. We don't just publish them. So when it becomes a patent, somebody can either buy it or use a license to use that, right? So it entirely depends on the IP arrangement or the IP agreement between the industry who you are working for. When it comes to publications, actually we already give our copyright or IP. So actually if you sign those agreements, copyright agreements, or copyright agreement is more about the publication, but in some journals the IP stays with the author. In some journals, the journal owns the IP. So it depends on which journal you're going with. If you feel that the IP that you're generating has commercial significance, you should never publish. You should try to make a patent out of it, or try to sell it in some way, not publish. Publishing is more for academic purpose, but it doesn't have any industry value.
Thank you, sir.
Sure. Please, one.
Good morning. My name is Mahmoud Hassan, and I am a student from textile engineering. Currently, I am in the first semester. So I have tried to listen the full session, and I have a question that if there is a possibilities to combine the both textile industry and the machine learning, because the textile machineries are there are so many textile machineries, and I have a particular question. If you can give me the answer. How can machine learning be applied in the textile industry for optimizing production processes or improving fabric quality? You have talked about You have talked about water quality and weather things and some stuff. So I have that particular question. For optimizing production processes or improving fabric quality.
Sure. So I have seen plenty of works using image processing or computer vision to detect faults in textiles. So that's a very common thing. So once the textile sheets and things are being produced, there are cameras being set, and as they pass through, images are being captured, and those images are being analyzed to see if there are any faults within this textile or the clothes sheet that is being prepared. So that's pretty common, and I'm pretty sure that there are commercial applications of that in textile industry for those kind of work. Your second question is more around optimization, or basically process optimization, right? I think people from industrial and production engineering, they use a lot of different types of optimization, and those which you possibly have learned by now, or you learn as you go through your different semesters about those different optimization methods. But yes, I think there are some good opportunities, like for actually you plug in these optimization algorithms with these process models. But you need to realize there has to be some kind of simulation of that whole process there. So for example, if there is some kind of process, I know this guy actually who works in this company that produces poultry feeds, right? And I think he manages everything. So to understand that process and the plugging that in with an optimization algorithm, it should not be a very difficult problem. The slide that I had on AI for design, which was basically used for optimizing the carbon absorption through those filters, that is basically equivalent pretty much to what you're saying. So instead of the CFD, I just need to replace that with that process model that you have in the textile industry, and it should work.
Another question I have, can I ask?
Yeah, please.
So I am currently in first semester. So if I want to work with you or do some research with you or with your team or further other teams, so which process I should take? Simply, what is the procedure to work with your team or another teams in international standards?
I mean, I don't work for any university, so with any university it's very easy to work. I was explaining to our Vice-Chancellor sir before the meeting, like what are the key impediments working with us, because we are a government-funded research organization. And I mentioned about the IP agreements and everything, and that's when actually things become pretty sensitive and difficult to do collaborations internationally. But I do have some university affiliations. If you want to work with anyone, like university researchers will prefer that you contact them, find a problem in common. I mean, you put in some free time to solve a problem and then write a paper together or two. And once you are in a position, then possibly pursue a master's or a PhD degree in that university. But I think the professors will invest their time very carefully. So just make sure when you approach them, you're equipped with enough knowledge and also equipped with enough soft computing skills to address the problem that they will be asking for. So make yourself ready before you approach them. That will be my solution.
Thank you so much, sir.
Sure. Okay, thank you.
CSIRO? Is it possible?
We just need to talk offline, right? So for example, we do have, as I mentioned in one of my second or third slide, we have collaborations with 4,000 institutions. So we are always open to collaboration. We just need to find a common ground and how we're going to share the IP and all this stuff. And if there is a benefit for CSIRO and BUBT jointly, then it's always possible, but we just need to find a common ground.
Common ground means, say, for example, that if we say that we want to enhance the research or like improving research capabilities, and we may help CSIRO and in exchange we want the help from CSIRO as well. It can be a common ground. We can help them and they can also help us.
Yes, I mean, something like that, but I think, as I said, we have got business development people and legal people who look into this kind of matters, but I can always talk from a research perspective, like something that's beneficial for our research. As I mentioned, like in Bangladesh, there are lots of data sources that should be very easily available. So occasionally we struggle with like finding a test bed where you can actually test our methods on. So if like, for example, you or your organization can help us collecting data, obviously by maintaining all the ethical protocols and privacy protocols and everything, then why not? We can always talk about those kind of things. Thank you.
Okay, thank you.
Sure.
Is there any restriction for sharing your data or training the machine or application in Bangladesh?
Yes, there are.
How you can help us initial phase? For example, we want to start some research with respect to Bangladesh. cannot help to us for sharing few data for training the machine?
I mean, if I share my data, I doubt that it's going to help Bangladesh, but in Bangladesh, you have got plenty of data. And as I mentioned, like, if you see that spectrum on the left-hand side of the foundation models, if we work on the foundation models, we can apply on any kind of data. So if we apply on Bangladeshi data, that will be beneficial for Bangladesh. And that is something.
We are scattering like what we are not stable. That is why I asked you, because you are stable now. So if you kindly share some.
We can talk about it, but I think that's not within my hand. Actually, I work for an organization, and there are some fixed protocols that we can do. But definitely, I'm always happy to help whatever is possible for me.
Thank you.